the universe is vast, and with every new discovery, we are inching closer to uncovering its secrets. Imagine a reality where not just our blue planet, Earth, has oceans, but countless distant worlds across the cosmos are covered in vast, endless seas. Some of these water-rich worlds are only hundreds or even millions of light-years away. Recently, the James Webb Space Telescope, JWST, a marvel of modern science, has unveiled the first real image of another world that could be hiding oceans of its own, potentially teeming with life. This remarkable achievement has made waves in the scientific community and beyond, captivating the imagination of people worldwide. But what does it all mean for our understanding of life in the universe? Could these distant, water-covered planets hold the key to answering one of humanity's most profound questions? Are we alone? As we look at the immense and diverse exoplanetary systems in the universe, it seems increasingly likely that we are not alone. In fact, some of the most fascinating discoveries made by the JWST suggest that the most common type of exoplanet could be something known as HII worlds, or high-water content planets. These planets are far more abundant than previously thought and might be more habitable than Earth, giving us hope that life exists not just on Earth, but on countless other worlds. Among these new discoveries is the planet K2-18b, situated 120 light-years away from Earth in the constellation Leo. K2-18b has quickly become a focal point for astrobiologists. This exoplanet is 8.6 times the mass of Earth, and it's located within the habitable zone of its star, meaning conditions may be just right for liquid water to exist on its surface. In addition to being in a region where water could remain liquid, K2-18b has shown traces of carbon-based molecules such as methane and carbon dioxide in its atmosphere. These are the same molecules that we associate with life on Earth, further fueling the hypothesis that life could be present on this distant world. What makes K2-18b even more intriguing is that it might not just be another rocky exoplanet like many others we've discovered in the past. Instead, it might be a water world, where vast oceans cover most or all of the planet's surface. This discovery raises fascinating possibilities about the types of environments where life could thrive. With evidence of water, organic molecules, and chemical processes typically associated with living organisms, K2-18b is a prime candidate in the search for extraterrestrial life. The JWST has provided unprecedented views of this planet, using its advanced infrared capabilities to study the composition of its atmosphere in exquisite detail. What makes these findings particularly exciting is the potential that these planets, especially water-rich ones like K2-18b, might be far more suitable for life than Earth. Researchers have theorized that these planets, being only slightly larger and warmer than Earth, could foster conditions where life is statistically more likely to emerge and flourish. The combination of water and carbon-based compounds could create a perfect storm for life to develop in ways that we are just beginning to understand. However, while these discoveries are groundbreaking, the scientific community remains cautious. The mere presence of water and organic molecules does not guarantee life. After all, even on Earth, not every molecule of water contains life. But the sheer possibility of these factors coming together on planets like K2-18b makes it more plausible that we might find life on other planets in the future. In fact, the discovery of dimethyl sulfide, DMS, in the atmosphere of K2-18b is a particularly tantalizing clue. DMS is a compound produced on Earth by marine plankton, which suggests the possibility that life, or at least biological processes similar to those we find in Earth's oceans, might be occurring on this distant world. The JWST's ability to detect complex organic molecules, like DMS, from such a vast distance is revolutionary. It has given scientists the ability to peer into the atmospheres of exoplanets with unprecedented clarity, offering a glimpse of worlds far beyond our solar system. And these aren't just any worlds, they could be home to entirely new forms of life. With its ability to analyze light passing through an exoplanet's atmosphere, the JWST can detect the unique chemical fingerprints of gases and molecules that could indicate the presence of life-supporting conditions. These findings have profound implications for our understanding of the universe. They suggest that life could exist in places we previously thought were inhospitable. The concept of life as we know it may no longer be the only way to define what constitutes life. With the discovery of organic molecules in a distant galaxy, scientists are now entertaining the possibility that life, or the building blocks of life, might have formed much earlier in the universe than we once believed. For many years, scientists assumed that life could only emerge after billions of years of cosmic evolution. But the recent detection of complex organic molecules in a galaxy that existed in the very early stages of the universe challenges that notion. It raises the possibility that life, or at least the precursors of life, could have arisen much sooner than we thought, even in the infancy of the cosmos. This discovery upends our previous understanding of how life forms and complicates the search for the origin of life itself. These breakthroughs are part of a broader trend in space exploration, one where we are no longer limited to searching for life in our own solar system. The James Webb Space Telescope has made it clear that the potential for life exists across the galaxy, and possibly the universe. As we continue to explore new exoplanets and distant galaxies, the question of whether we are alone in the universe is beginning to seem less like a matter of if and more like a matter of when we'll discover other forms of life. Perhaps even more incredible is the realization that these exoplanets, which have just recently been discovered, could be more than just barren, rock-riddled worlds or inhospitable gas giants. Many of these planets are what scientists call mini-Neptunes, water worlds that are smaller than Neptune but still have vast oceans covering their surface. These planets, while not quite like Earth, might offer conditions that are far more suitable for life than we've previously imagined. In fact, they may be the most common type of exoplanet in our galaxy. This shift in our understanding has profound implications not just for our search for extraterrestrial life, but for our entire conception of life beyond Earth. The discovery of HII worlds, planets with high water content, could radically change how we think about life in the universe. These planets might not only harbor oceans, but they could be home to ecosystems and life forms that we have yet to imagine. And as we continue to study these exoplanets with advanced telescopes like the JWST, the possibilities become even more exciting. We may not be far from discovering life on one of these planets, or at least identifying conditions where life could thrive. The information we gather today could lay the groundwork for humanity's next great leap, discovering life beyond Earth. But as much as we've learned from K2-18b and other distant exoplanets, our search for life doesn't stop there. Even within our own solar system, the hunt for extraterrestrial life is in full swing. While Mars has long been a focus of exploration, with its past evidence of liquid water and the discovery of organic molecules by NASA's Curiosity rover, it is the moons of Jupiter and Saturn that are now drawing the most attention. These icy moons, such as Europa and Enceladus, are believed to harbor vast oceans beneath their frozen surfaces, making them prime candidates in the search for microbial life. Europa, in particular, is a top target for exploration. NASA's upcoming Europa Clipper mission will venture to this moon, searching for signs of life in its hidden ocean. If there are life forms on Europa, they may have evolved in ways that are completely different from anything we know on Earth. The subsurface oceans of Europa could be warm enough to support life, despite the moon's icy exterior. Similarly, Enceladus, with its geysers spouting water vapor and organic molecules into space, offers tantalizing clues that life could exist beneath its icy shell. Beyond these moons, other parts of our solar system, such as the asteroid belt, also hold clues to the origins of life. Recent missions like OSIRIS-RX and Hayabusa-2 have collected samples from asteroids, revealing that these rocky bodies are rich in organic molecules and water. These findings suggest that the building blocks of life may have been spread throughout the solar system early on, potentially even seeding life on Earth. The discoveries of organic molecules and water on asteroids and comets challenge our understanding of where life could arise. While we have long focused our search for life on planets and moons, these small bodies may have played a critical role in the early development of life in our solar system. The more we study them, the more we realize that the conditions for life might have been present much earlier in the solar system's history than we previously thought. As we continue to explore distant exoplanets, moons, and even asteroids, the future of space exploration is incredibly bright. With new technologies and missions on the horizon, we are making exciting progress in the search for life beyond Earth. The James Webb Space Telescope, in particular, has provided us with a glimpse into the depths of the universe, and its discoveries are transforming our understanding of the cosmos. With future missions like the planned LUVOIR and Origin Space Telescope, we will be able to peer even deeper into distant worlds, unlocking new secrets and pushing the boundaries of what we know about the universe. In the coming years, the question will no longer be whether life exists elsewhere in the universe, but how diverse and widespread it might be. Whether on distant water worlds like K2-18b, moons with hidden oceans, or even asteroids and comets, the search for life is just beginning. And as we look to the future, we can't help but wonder, what other secrets does the universe hold, just waiting to be uncovered? The answers to these questions could reshape everything we know about life, the cosmos, and our place within it. The discoveries we're making today are just the beginning of what promises to be a new era in space exploration. As we continue to explore and uncover the mysteries of the universe, we can only hope that we will soon have definitive proof that we are not alone. And when that day comes, it will mark the beginning of a new chapter in the story of humanity, one where the possibilities are as vast as the universe itself.